Hello everybody. Thank you for joining our class, the first class of organic chemistry, grade 12. Organic chemistry, or what we call chemistry paper 2, is one of the easiest paper you can pass, and you can get all the marks. Just keep yourself on to this channel. You'll be able to obtain a distinction. It is M.Saidi as usual. Let's go through. If you have any challenge, let me know so that I can solve that problem. It is an introduction which is going to aid or help you to understand the other subtopics under this organic chemistry topic. All right. Under organic chemistry, you need to know some of them. Organic chemistry is often described as chemistry of carbon based. Actually, what you're going to be dealing with here is basically carbon. And then you need to know where is carbon found on the periodic table. Carbon is found on in group 4. Group 4. What does it mean? It means that it is able to donate or to share these 4 electrons which are remaining. Remember, it is supposed to be 8 on the outermost shell. But now, because it is found in group 4, it is remaining with the 4 electrons to become 8, to be stable. So, it is found in group 4, and because of that, it has unique characteristics which you are going to have to see, or which I'm going to share with you, and that is going to make us understand the concept of organic chemistry. You need to maximize all the marks in this organic chemistry. Why? Because here, once you get, at least you'll be having something like 40% of the paper. And it is very simple for you to understand this. All right. Carbon atoms have ability to form 4 bonds. That's the meaning. That's what I said here, that it has ability to form 4 bonds. And because it has ability to form 4 bonds, then definitely it means that it is able to form other. You see, this is free electron which can bond with another atom, and then this, and then this, and then this. So what does that mean? It means that it can allow 4 atoms to be attached on it. So we need to understand that, so that you know that whenever they give you a compound of carbon, the carbon must have 4 bonds. If you have more than 4, then that molecule is going to be wrong. So make sure that whenever you write carbon, make sure that you have to find out whether they are 4 bonds or they are short than that. If they are short of 4 bonds, then automatically you get it wrong. So make sure that whenever you write carbon, it is supposed to have 4 bonds. So I think that one is very clear. Carbon can undergo a process known as hybridization, meaning that it can allow other sites, it can allow other electrons to be bonded with the this molecule. So we're gonna see it that, but not that much, but we'll just understand the concept as we continue. All right. Before I talk about the classification of this organic molecule, let me just talk about this. This carbon atom, you see that carbon, we are only talking about carbon because carbon is unique. It is unique in its group 4 molecule. It can have ability to bond with another carbon, carbon with carbon with carbon with carbon, you see, which is not possible. Hydrogen with hydrogen, never. It can't be like that. Oxygen with oxygen with oxygen, never. So because of this ability to join with its own atoms, in science we call it catenation, has ability to link with another atom with another atom with another atom of the same kind, which is carbon. So in science we call it catenation. These chains, these atoms can form a chain of thousands of carbon, and once we reach there, then we shall say that it has formed what we call a polymer. An example of a polymer which I can give you to understand better in organic life is a protein. It has many molecules of carbon. It is carbohydrates. Yes, it has many molecules of what? Of carbon. So it is a polymer of carbon. It is many molecules of carbon. Yes. So it has that ability that it can form long chains of these molecules. So carbon has ability to make single, check, double, check, triple, check. So those single, double, and triple, they mean something different in chemistry. And because, for example, if carbon can form another bond with another molecule, so we call it a single bond. But now if I have carbon with another carbon, double bond, so this molecule A is going to react differently from molecule B. And then it's can form a triple bond C. This molecule A is different from this molecule B, is different from this molecule C. So it means that however much they look the same, but this one has a single bond, this one has a double bond, and this one has a triple bond. Therefore, carbon has that ability to form those multiple bond or single bond or double bonds. So it is also making it to be unique from other molecules. All right, let's find out some of the organic molecules we're gonna be looking at this time. Organic molecule is divided into two. The first one is going to be hydrocarbons. When we talk about hydrocarbons, we're going to look at them in detail. We are talking about hydro, which means hydrogen, and carbon, which means, yes, hydrocarbon. It means that these are molecules, these are compounds which contain hydrogen and the carbon only. Molecule, hydrocarbon, when you talk about a hydrocarbon, these are molecules which contain hydrogen and the carbon only. We will ask you this question in any paper we say. What is a hydrocarbon? Identify the type of molecule. Is a hydro. Why do you identify it as a hydrocarbon? Because it contains hydrogen and carbon only. That word only must be there. Then we have what called the derivatives of hydrocarbons. What we obtain from hydrocarbon. When you add something on hydrocarbon, what do you form? So we call them derivatives. It means that carbon, hydrocarbon, for example, let me give you an example. You have milk. But if you have porridge, you have poured milk in the porridge, so that could be a derivative of milk. You see, it has another mixture. You have milk is a mixture, but now you have added this flour in that milk, so it becomes a derivative. So that's what it means. So we look at what you call the aliphatic, which means just chain without forming rings, which include the alkane, alkene, and alkyne. We look at them as a topic. This one, we won't look at it. If you find a book having it, please don't waste your time. Don't look at that. Take it out. However much, there are so many books which have them. You understand? Because they need to be updated. We look at what called a haloalkane, halogen alkane, which means that is a hydrocarbon linked with an alkane. With a group 7 element. Alcohols, we look at alcohols. Carboxylic acids, esters, these are brothers and sisters. Ketones and aldehydes, these are also brothers and sisters. We're going to look at them into detail. What do they mean when they talk about that? All right, let's go to organic chemistry in simple terms. All right. Organic chemistry or organic molecule can be defined as molecule containing carbon atoms. So I've explained. So molecules which have many carbon atoms, we call them organic molecules. You must know how to write what you call a condensed structure formula. So guys, what I'm trying to say here, these are some of the terms you need to know when you go there. When you are going to be talking about this organic chemistry, you must know these terms we're going to be talking about. Number one, condensed structure formula. When you talk about condensed structure formula, what does it mean? Then you have what called a structure formula. What does it mean? We have what called a molecular formula. What does it mean? So let me show you what it means. Now I have a molecule. I write it like this. I will not say the name because we have not reached there. I write it like that. So in this case, they ask you to write the molecular formula of that. Write the structure formula. Write the condensed structure formula. So when it has hydrogens, remember these are hydrogens, you must always put those hydrogens there. So now I have something like that. So now we are starting the journey, the real journey. All right. This is what you see here is what called a structure formula. So that is a structure formula. But what if they ask you to write the condensed structure formula? What do you do there? So you have to count how many hydrogens, how many atoms on each atom. I'm going to explain that. How many hydrogens are on each carbon atom? For example, I go to that one, central atom in that case. C, how many are they? It's 1, 1, 2, 3. I have 3 hydrogens. Then I go to this one, C, 1, 2. I have 2 of them. Then I go to this one, C, H2. Then I go to this one, C, H3. So now it becomes a condensed structure formula. This is a structure formula. It must show all the bonds. It must show all the bonds in an atom. Condensed structure formula, it shows how many atoms are bonded with each other. Like if this is the one they are talking about, how many hydrogens and how many hydrogens are linked to that carbon atom. So now it becomes a structure formula. So you show the bonds on each, but now if you are condensing them, that's why we say condensed structure formula. I think I'm clear there. What about the structure formula? When you talk about the structure formula, what does it mean? When you talk about structure formula, you count how many hydrogens and how many carbons are in there. For example, 1, 2, 3, 4. So I have 4 carbons. And how many hydrogen do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 hydrogen. So this one becomes the molecular formula. This one becomes this one, the condensed structure formula, where I don't show the bonds, while this one becomes the structure formula, where you show all the bonds. Then we need to know what we call, or we will see what we call IUPAC naming. We have a standard way how we name the compounds. And why should we have this naming system? It's because we need to have a unique way how we're supposed to name this all over the world, so that we prevent this confusion. which might happen, so that the science has unique language. For example, let me ask you a question. How do you call God in your language? You have the specific way how you call God in your language. When you go to another language, for example, in Tswana, they will call God differently. In Zulu, they will call God differently. In M.Saidi, they will call God differently. In English, they will call God differently. In Arabic, they will call God differently. You see? So, you'll find out that you might not understand if you're using the other way around. But now, if you are using the unique way how we're supposed to name, then we'll be able to understand. That's why we'll have to know the IUPAC names of each compound we'll be talking about. And this will have to constitute some marks. When we are marking, expect questions concerning about naming the organic molecules. So we'll look at it in detail. So you need also now in these organic molecules, we need to have what you call the alkanes. Here, please don't talk about the rings. Don't talk about the rings, structures which are involved in rings. So here, this is an example of a hydrocarbon. All these three are hydrocarbons. These are the parent of all molecules. When you talk about alkanes, alkanes can be differentiated from other molecules by single bond. This compound will only have carbon and hydrogen only, and it will be single bond. So when you say a compound which is single bond throughout, we call it an alkane. That is an alkane. So alkane, in other words, means single bond. Hydrocarbon, yes, a compound with carbon and hydrogen, and bonds in that molecule must be single bond throughout. Then you just know that that is an alkane. What about an alkene? Alkene. Yes. Alkane, we will see these molecules in detail. Yes. This is just a simple introduction. Today's lesson is just a simple introduction, so that when we go to other subtopics, we'll be able to understand, and I'll be able to refer to you that I said this in this lesson. All right. Alkane, it means, in other words, this one means double bond. Double bond between carbon atoms. You'll see at least two carbon atoms, they have a double bond. In other words, when they say alkane, you have to be carbon and hydrogen throughout, but it must have a double bond somewhere. That's what it means. We shall see how do the general formula, the naming, all that we shall see, and I'll show you how simple this could be when you go with our lessons. Then we go to alkynes. If you are a scientist is always observing. If alkane is single bond, alkane is double bond. What about alkynes? Definitely is gonna be a triple bond. So this means what? Something which has a triple bond. So it means that I will see 3 bonds in there. So this alkyne, it means triple bond. Compound which has a triple bond. That's what it means. So we're going to look at these molecules in detail. But now you have to remember that when I say alkane, it means a single bond. Alkene, it means a double bond. Alkynes, it means a triple bond. If you don't understand something, please let me know in the comment section so that I can answer that immediately. Alcohols. Does this mean alcohols people drink? I won't say alcohols we drink. I don't drink. Yes. Okay. Alcohols. Yes. We mean some of the alcohol people drink is also involved there. But sometimes we're not talking about only that. That is just a simple part of alcohol. If you check the medication you take, you'll find out that they will talk about alcohol. But sometimes you don't know it. When you talk about the perfumes you use, it contains alcohol. So it means that we are not talking about the alcohol we are the people sell in the shops. All right. It is also involved, but it's not restricted there. All right. Alcohol has, when you talk about alcohol, we shall see its functional group, that this alcohol, they have an OH is attached to a carbon. It has that, something like that. Yes, it is attached to carbon. But now, how do I know? How will I know? I'll teach this alcohol in detail. Don't stress about it. This is just an introduction, whereby you understand better when you reach there. But the key point here, which I need you to understand, is we have seen that alkane is single bond, alkene is double bond. Whenever I say double bond is alkene, alkyne is a triple bond. What about alcohol? The carbon is, the OH is attached to carbon. You see, OH, you see, yes, is attached to carbon. But now this alcohol has a primary, a secondary, and a tertiary. When you talk about primary alcohol, yes, it means that it is in level 1. When you are in your primary level, what does it mean? You are in level 1. When you're in the secondary level, you are in level 2. When you're in the tertiary level, you are level 3. So what does it mean? Here in this case, here alcohol is attached to one carbon atom, like that. While secondary alcohol, you will find out that the OH is attached to 2. It's like that, but this side you have a carbon atom and this side you have a carbon atom, meaning that this one is in the middle. Here, this one is at the end or at the beginning. It depends on how do you differentiate it. So this is a primary. And then this is a secondary. And then tertiary, it means that, remember, level 1, level 2, level 3. Do you understand? Yes. It must click in your mind that when you say primary, what does it mean? It means level 1, one carbon atom attached, bond. It's only one carbon atom this side. Secondary, to level 2, 2 carbon atoms. I'll explain this in detail. Don't stress. When you go to alcohol as a topic. Yes. Then you have tertiary. Tertiary means 3. Therefore, I'll write carbon. Then I have one carbon atom here, one carbon atom here, and then another carbon atom there. So meaning that the OH is attached, check. This group, it has 1, 2, 3. So 3 levels. This one, secondary, the second level. 1, 2. It has only, and then primary only has 1 level. So meaning that the carbon atom with the functional group is, okay, I'll explain that better. But you need to know that the OH is attached to the carbon with one carbon. The OH is attached to a carbon atom with 2 carbon atoms. You see? While here the OH is attached to carbon atom with 3 carbon atoms. So I'll explain this in detail when we reach the carbon atom, with the alcohols. So don't stress, just keep in touch. If you don't understand, let me know in the comment section. All right. Oh, we have what called the carboxylic acid. Carboxylic acid. Do you know carboxylic acid? Let me see. What is carboxylic acid in the daily life? The best example is vinegar. Vinegar is an example of a carboxylic acid. Yes. So you see that you're talking about only organic things. So carboxylic acid, how do I differentiate it? You will see that a carbon atom has 2 zeros, 2 O's, and a hydrogen. That is a carboxylic acid. Once you see it like that, once you write a compound, and you see it has 2 O's with a hydrogen, listen carefully. I didn't say that 2 O's, just that like that. I said 2 O's with a hydrogen at the end. It must have a hydrogen at the end. Why am I saying that? Because I'm saying that because the sister of that is gonna look like this. If it is like this, see, okay, this, and then I have another, maybe another carbon atom. This could be how many carbon atoms, it depends. Yes, check here, whereby here the hydrogen is ending, while here it's not hydrogen, it's something else. It could be another molecule of carbon atoms. So that's the difference. So you just know that, okay, once you see it like that, you just know that that is an ester. While this one, that is a carboxylic acid. So these two, we call them sisters and brothers. We shall see it when we go to each topic in detail. So it means that I've talked about the esters. Then we're going to also look at another functional group, or another group which we look at. We call them haloalkane. This comes from the word halogen, which means group 7 elements. Group 7 elements. But now I have a primary first level, secondary second level, tertiary third level. What does it mean? It looks like to be alcohol, but in this case, I will replace this OH with a halogen. Remember, in group 7, the elements we talk about, you can talk about the fluorine, the chlorine, the bromine, the iodine. Those are the elements we talk about in group 7. So now, if it is a primary, it will have, for example, let me just call it X. Let me just call it, because it could be this, could be this, could be this, could be this. So let me call it X. Let me call it X. So this will be maybe X. It will have many hydrogens and what, but it will have an X or one of these at the end. You see, it only has one of it. This can be hydrogen, but this should be a carbon or a hydrogen. This can't be carbons, no. Second level, meaning that you have, what do you have? This one, this X, any of this will be linked to this, the carbon atom. It has 2 carbon atoms attached, meaning that second level. You see, this one is a primary level whereby this molecule is attached to 1 carbon atom. You see, but now this one, this molecule is this one of these atoms is attached to a carbon atom with the 2 other carbon atoms. It means that definitely this must be hydrogen. What about a tertiary? So we shall say this is a primary haloalkane. Why do we say haloalkane? Because it is an alkane with a halogen, hence haloalkane. So we shall call this one primary. We shall call this one secondary. While tertiary will have to be like this. Still the other one, but now the X is there. So it means that this carbon atom with the X, or with either any of these, is bonded to 3 of them, meaning that I'm on the 3rd level. Sometimes we call this primary, secondary, and then that tertiary. But in exam, say primary like that, secondary like that, and then tertiary like with the way we write it, tertiary haloalkanes. So guys, I think it is getting better. If you have any question, let me know in the comment section so that we can help you out. We shall see some examples when we reach in that specific aspect. We will talk about them. Don't stress about this organic chemistry. Don't be biased with this chemistry. I know that many people, they have problems with the chemistry in grade 11. Sometimes we don't put attention in chemistry, but I'm telling you, when you keep yourself on this channel, you will enjoy what we call chemistry, and you will get a distinction. Just to do what I'm telling you to do, you will see what is next. So we saw the esters. What about aldehyde and the ketones? Aldehydes and ketones are also brothers and sisters. So aldehyde, look at this critically. The carbon has, look at this. Is it like that? Yes. The carbon which has oxygen, the oxygen is a double bond. Let me change it. Okay, double bond. And then it has a hydrogen like that. So Remember, it is group 4. Everything must be 4 bonds. 1, 2, 3, 4. You see? So this could be another carbon atom. So let me just call it R. When I say R, means the alkyl group. It will be any number of carbon atoms going that side. Maybe 1, 2, 3, 4. It depends on how many carbon atoms are there. So let me just call it an alkyl group. So when I condense it, you will find it looks like that. With that. You see? Yes. So this one is different from alcohol. Look at this. Alcohol, the way how it looks like. We say that alcohol, for it, the oxygen, the hydrogen is attached onto oxygen. So it's a single bond. It's a single bond. While here, the hydrogen is attached onto carbon. So the oxygen is double bond. So that is a major difference. Please don't confuse aldehydes with alcohols. What about ketones? It's the same as aldehydes, but the only issue, this is replaced with a carbon atom. So for example, I will have C. Let me just do it like this. Let me just put this one on top. Doesn't matter. And then I have this alkyl group. How many carbon atoms? Doesn't matter. They can be 2, they can be 3, they can be 4, they can be 5. Doesn't matter. Then this side also have another carbon atoms. Can be 2, 3, 4, 1, whatever. Doesn't matter. That's why so meaning that now that is a functional group. That's what makes it to be ketones. Guys, don't stress. We will understand this better. This is just a hint to show you what you're gonna see in the next classes. It's gonna be easy for you. Everything is gonna be all right. So just stick, pay attention, then we shall continue. Then we'll be able to understand. Sometimes I'll open the lines, meaning that whereby I ask students to ask questions direct, or sometimes we'll use our website whereby you can see me direct, I can see you direct, everything, so that at least there is maximum explanation and the interaction. Yes. So those are ketones. So the major difference between the aldehydes and the ketones, the aldehyde, they don't have any carbon atom here. They only have a hydrogen and it's always at the end. Well, if you look at this one, you'll find it's like this. You see? It's like that. So meaning that this side there is a alkyl. Let me just... When we talk about the molecular formula, you have to... A molecular formula, you have to condense everything. How many carbons do you have? For example, I say 1, 2, 3, 4, 5, 6, 7. And then now you have hydrogen throughout. Hydrogens. Then now you put your hydrogens there. You put your hydrogens there. You put your hydrogens there. You see? Check. You put your hydrogens there. Yes. You put your hydrogens there. Sorry. Hydrogens there. You put your hydrogen there. Put your hydrogen there. Yes. This one looks untidy. Yes. You put your hydrogen there. You see? Now, they want you to write the molecular formula of this compound. Simple. How do you do? 1, 2, 3, 4, 5, 6, 7. How many do I have? I have 7 carbon atoms. I'll say 6, C, 7. How many hydrogen do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So hydrogen is 16. So the molecular formula is done. Is that difficult? However, sometimes we can give you the molecular formula to write the structure formula like this. Anyway, we shall reach there and we'll talk about it. Yes. So whenever I talk about the molecular formula, you have to write how many carbon atoms are there, how many hydrogens are there, how many oxygens are there. Simple. Just count. Yes. What about structure formula? Structure formula, we saw it. We saw it nicely. And we say that now if I have for example, let me just say something here, H2N, maybe I have 2 I have 2n, yes, I have 2, I have here, it's going to be 2 times 2, so it's going to be 2 times 2, which gives me 4. All right, I have C2, yes, H2, 2 times 2, H4. Yes, yeah, like that. Don't mind about this. I was just creating just to show you how C2H4, and then they ask you to write the structure formula of that. When they give you something like that, this is the molecular formula. You see, it's like this. But now I want to write it like that. So it's gonna be C. How many carbon atoms do I have? 2 of them. C. So there are 2 of them. So simple. How many hydrogen do I have? I have 4. Okay. But don't forget that each carbon atom is supposed to have how many? 4 bonds. So I'm gonna put, okay, let me put 1 hydrogen here and another hydrogen here. So 2 of them have gone. I put another hydrogen there. I put another hydrogen there. All the hydrogens are gone. So I have hydrogen, 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 hydrogen. How do I make this molecule? So I have 1, 2, 1, 2. How do I make this molecule so that each carbon atom is having 4? So I put the first bond. So it's going to be 1, 2, 3. You see? Even this one is going to be 1, 2, 3. What if I add another one? So it's going to be 1, 2, 3, 4. Perfect. 1, 2, 3, 4. Perfect. So it means that this one has 4 bonds, and also this one has 4 bonds. So writing like this, you are writing the structure formula. So I can give you the molecular formula to write the structure formula. I can give you the structure formula to write the molecular formula. This is an example of a structure formula. I can ask you to write the molecular formula of this. Yes. So we will see all this in detail. Yes. So for example, I come here, if they ask you to write the molecular formula, so I'll come here, I'll say this is, no, let me start with the condensed structure formula as we saw it up. We'll say that this carbon, it has how many hydrogens? 1, 2, 3. So is there the 3. Then this carbon has 2 of them, H2, sorry. This carbon has 2 hydrogen. What about this one? It has nothing, but it has oxygen, you see. And then this one, it has 3. You see? Yeah, it becomes simple. It becomes what? Simple. Yeah. What about when I want to write the molecular formula of this? So this is a condensed structure formula. What about if I want to write the molecular formula of that? Molecular formula of that, I can write it how? I can write it by saying that how many carbons do I have here? I'm going to say 1, 2, 3, 4. Or I can write 1, 2, 3. 1, 2, 3, 4. Say C4. How many hydrogens do I have? Let me start from here. 1, 2, 3, 4, 5, 6, 7, 8. I write hydrogen 8. How many oxygen do I have? It's 1. It becomes that. So this becomes the molecular formula. This becomes the condensed structure formula. And then this becomes the structure formula. So you will get it right. Just keep in touch. By the way, don't forget to subscribe, like, and also share to others so that they don't miss out. Every day we have a class on this channel so that we push you up and you read ahead. Yes. So in other words, we have shown you how do you write the condensed structure formula. So we say that this is the condensed structure formula. That's what they are trying to show you. It does not show all the bonds. You see, doesn't show those bonds. Yes. So it must be, it shows the number of atoms, CH3, CH2, CH2, CH3. You see, it doesn't show the number of carbon atoms. However, we can also have something like this. It is also called the condensed structure formula, something like this. for other molecules like CH2, CH3, CH3, and then I put a double bond there. It's also a condensed structure formula. It doesn't show all the bonds. Yes, it can show some bonds, but sometimes it doesn't show completely. Sometimes we can hide them and we write it like that. And they ask you to write the structure formula for that. You need to know how many carbon atoms, how many bonds are on each carbon atom. If you distribute all the hydrogens and they are finished, the only option you have to take is to introduce a double bond or a triple bond somewhere so that you are covered. Let's go to the next question. Hydrocarbons. What do you mean by hydrocarbons? We talked about it. We said that hydrocarbons, these are molecules which contain hydrogen and carbon only. When we are setting the exam, we shall say that we need to see the word only. Ne? If you don't write the word only, ne? Carbon and hydrogen only. Yes. So examples here, we talk about alkane, alkene, and alkynes. Alkane, alkene, and alkyne. Alkynes. Alkanes, alkenes, and alkynes. Those are the hydrocarbon, the core of the hydrocarbons. Homologous series. Oh, yeah. Here, the story begins. A homologous series, when you talk about homo, in science means the same. Logos, it means the structure, meaning that these structures, they have the same, something in common is there. Same structures, they have the same structures, or same general formula. They have the same general formula. The general formula, for example, we shall see them when we go to alkanes, ne? Or alkene. CH2N plus 2. So all the alkanes, they will have that general formula. All the alkenes, they will have that general formula. And all the alkynes, they will have that general formula. All of them, doesn't matter how many carbon atoms do you have. We shall see this in detail, don't stress about it. But I want to show you that it has something in common, which is the general formula. The general formula doesn't matter, but the number of carbon atom keeps on changing. So that's why here we are saying that you're saying that series of organic compound that can be described by the general formula. You see, the general formula is the same, or in which one member differs from the next by just CH2. Yes. For example, let me give you an example here. You understand what they mean with the homologous series. Same homologous series. Alkane. Alkane. I will show you, ne? But I'm not going to say the name because I don't want to confuse you. All right. CH4. CH3. 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 CH2. CH3. CH3. CH2, CH2, CH3. You see? This one differs from this by this CH2. You see? It's been added. This one is differing from this by this CH2. You see? Yeah. What about this one? This one? Still the same. Because this one, there are 4. This one is there are 3. If I subtract 1 and I put it here, I'm just showing. If I subtract 1 hydrogen and I put it here, then this one is going to be like this. You see? So still this one differs from this by CH2. So that all homologous series, they are like that. They are differing with CH2 from one member of group with another member of group. You understand? It's like when you're in grade 12. What makes you different from grade 11? It's just a class, just one class. The grade 11s are different from grade 10s by just one class. You see? And it makes it to be totally different, to be a different structure. Yes. So that's exactly what happens when you do that. Luyanda is asking me, Minir, if I say a hydrocarbon are molecules that consist of carbon and hydrogen only. Yes, is correct. Carbon and hydrogen only. Yes, is correct. The order doesn't matter. As long as we see the word hydrogen and the carbon only. Yes, then we shall give you a mark. The word only must be there. Yes, we want to see it. Then we go to what you call saturated compounds. Luyanda, thank you very much. I think it's clear, ne? Saturated means something which you cannot add. It is full. When you are full, you are saturated. You are full of food, you are saturated. You understand? Yes. So compound in which there are no multiple bonds. It means that you have single bond between the carbon atoms. Single bond between carbon atoms. So for example, alkanes. An example is alkane. It has single bond throughout. Ne? Hydrogen, 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 hydrogen. You can pick any alkane. I just picked that. You can pick anything else. Yes. What about alkene? Remember we said that alkanes is single bond. What about alkenes? Alkenes will have double bond. So it becomes unsaturated. It means that this bond can break to accommodate other molecules. You see? 1, 2, 3, 4. 1, 2, 3, 4. You see? 1, 2, 3, 4. Yes. What about alkynes? Triple bond. We said so it's also unsaturated. Yes, it's also unsaturated. So I have 1, 2, 3, 4. 1, 2, 3, 4. You see? Yes, it is also unsaturated. So unsaturated compound, they have one or more multiple bonds between carbon. That word must be there. Between. Don't say compounds which have two or more. Compounds with sorry, this one is not one. It's supposed to be two. Compounds with two or more multiple. No. The English is correct. Compound with one or more multiple bonds. Or compound with two. Check. Stop it. Technology. Just a moment. Just a moment. Yeah, okay, it's back. It has two or more multiple bonds. Two or more bonds between, don't say multiple, two or more bonds between carbon atoms. Two or more bonds between, not two or more multiple bonds. Because the word multiple means many. Yes. So it has two or more bonds between carbon atoms. So it has two or more. You can say two or three bonds between. You understand? Yes. So what you want to see that it is not single bond throughout, but the word between carbon atoms must be there. Why? Why should it be between carbon atoms? Because I can have something like this. You see? The double bond is not between carbon atom and carbon atom. It's between carbon and oxygen. So that's a different story. Where do we find the saturated and unsaturated compound in our daily life? Fats and oils. Yes. The cooking oil, you call it what? Fish oil. Fish oil. Yes. And then the butter you are eating, you are spreading on the bread. Yes. Those blocks you get from ShopRite. Yes, those are some of the examples. When you eat the fats from the meat, Yeah, those are some of examples of saturated and unsaturated. Yes. Functional group. Guys, the word functional group and the word homologous series, those ones you will find them concurrently. They are going together. Okay, a bond, or it could be a bond, like we say the single bond, double bond, triple bond. So a bond could be a bond. It could be an atom like fluorine, or it could be a group of atom, OH. You see? Yes, it could be carbon, because we said here carbon atoms. We said here that this one is made up of single bonds. Where is it? Yes, we say that these alkanes, they're made up of single bonds. Yes, we talked about them. Yes, made up of single bond. When you say single bond, it helps it to react that way. And we said double bond, it helps it to react that way. Then triple bond, it helps it to react that way. So that's what it means. So when it could be a single, it could be single bond, it could be one atom, it could be group of atoms. That determines the physical. It could be a physical and chemical properties of that organic molecules, or that organic compound, that homologous series. Yes. So we call it a functional group. Actually, it's a group. Don't say it like this. But it's a group. I'm just explaining in layman's language. It's a group which make that molecule to react the way it reacts. Why do you behave like that? Because I'm a Zulu. Why do you behave like that? Because I'm a Tswana. Why do you behave like that? Because I'm a Pedi. Why do you behave like that? Because I'm a vendor. You know that vendors, they behave differently from Tswanas. And you ask someone, said, which kind of lady do you want to marry? Then someone said, I can't marry from that tribe. Why? Because you know a specific character which is found in that tribe. You understand? So that is the functional group of that tribe. The tribe has the way how it behaves. You understand? That tribe has the way how it behaves. You understand? Yes. So these molecules, that they have a specific way how they behave, and that group of atom could be atom, it could be a bond, it could be something else, is the one which makes them to behave the way it behaves. We call it a functional group. Guys, are you understanding what I'm trying to say or what I'm trying to teach? I don't want you to get lost, so that, because when I'm going for the next class, I don't want you to be lost completely. You understand? You need to understand the concept of all this, of whatever we are talking about, so that when we come for the next class, you are 100% perfect. We are looking for distinctions, guys. Isomers. Isomers. Let's finish up with these isomers, so that we shall see what we can talk about. That is nomenclature, the next class. Isomers. Isomers, iso means something same, still same. It is like homo, but in this case, we are looking at building blocks which are the same or different. Organic molecules with the same molecular formula but different structure formula. They have the same molecular formula but different structure formula. I can give an example in layman's language. Yes, let me give an example in layman's language. Humans. When you talk about humans, human beings, people from Botswana, let me say Botswana, and people from Zimbabwe, and people from South Africa, and people from Malawi, whatever. All of us, we are the same. We are the same. Why? Why are we the same? We are just different outside, but inside we are the same. We have the same makeup. So the same, the formula which made us up is the same. So you don't need to look at someone else in a different way, because this one is from Botswana. This one is from the... You don't need to look at them that way, because we have the same genetic makeup. We have the same makeup, But what makes us different is outside. No, we people from Limpopo, yeah, we are dark skinned. Cool, perfect, nice. You understand? We people from Eastern Cape, we are light skinned. Cool, perfect. Is this just a structure formula? If I cut a skin, we will have the same blood, same type of blood coming out. So the structure formula, the way how you make up yourself is different, but what made up of you is the same. Same molecular formula, but what is different is the structure, the way how you arrange. Same component you use to build a house, but the way how you mix, you arrange these bricks makes the house, the shape of the house to be different. That's what they mean. That is an isomer. All houses are the same, but they're isomers. They have different structure formulas, but the same molecular formula, same. That's why you'll find out that the same people who are building are the same, but because you have a different plan, the way how these bricks are supposed to be arranged is different. Then makes the house to be different, but it's the same. All right, let's go. We have three types of isomers. The first one is chain isomer. We can be different by the structure. You understand? We can be different by the structure. Yes. We know you are big, the other one is small, the other one, you see. We are the same, but because of the size and so we are different. Yes. We can be different by the positions. You think your principal and the deputy principal and the teachers and the cleaners and the what are the same? No. They are different. They are the same outside because they eat the same food. They eat what? We do the same thing. The principal, you the principal and you the cleaner, you don't have any difference. You are the same. Sorry to say this. You eat the same food. You can eat the same food. You go to the same toilet. You see what is different? The only thing which is different there is the position. So I'm gonna explain everything. Ne? Just giving you a simple example. And then you have what called a functional isomer. How do you function? How do you treat yourself? You can be respected because the way how you function yourself. You see? Yes. So we are the same, but the way how you function yourself, it becomes functional isomer. So when you are defining all this, chain isomer, you will say same molecular formula, but different chains. You see? Chain isomer. When you talk about position isomer, same molecular formula, but different positions of the side chains. You see? Different positions. You see? Same molecular formula, but different functional isomer, different functional groups. You see? Yes. So you need to know that. We will explain this much more better. This is just an introduction for the class. Is it clear? Yes. So here you see that this chloride is on carbon atom number 1. The chloride is on carbon atom number 2. 1, 2. You see? So the way what is different there is the way how this chloride is arranged. It's just the structure is the same. So sorry, the molecular formula is the same, but the way how you arrange it is different. 1, 2, 3, 4. I have 4 of them, but now yes, with hydrogens all over. Ne? And then now I have 1, 2, 3. I put the 4th one here. Still is the same, but if we count the number of hydrogen, we'll find out that it's the same. Carbon atoms are the same. 1, 2, 3, 4. See, the same. 1, 2, 3, 4. You see, 1 carbon, 2, 1 hydrogen, 2, 3, 4, 5, 6. 1, 2, 1. Yes. Okay. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 10. What about here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10. You see? It's the same thing. So it's the same thing. So we call them structure isomer. The way how this main chain is branched and arranged makes it to be different. We shall look at the isomers more in detail. All right. Position isomer. Now this one, it changes the position of the functional group. Yes. Okay, this is the functional group, the double bond. Remember, it reacts in a specific manner. This is a functional group. And then here, it is at between the first and the second. Here it is between the 1, 2, 3, between the second and the third. You see? So it becomes, even the naming, you see, bute 1 in, bute 2 in. You see? So it is different. So we also call it an isomer. Why is it an isomer? Same structure formula, but what is different is the position of the functional group. If you count the number of hydrogen carbons which are here and hydrogens and carbons which are here and here, you'll find out that is the same. So, but what is different is the position of the functional group. Functional isomer. Now here you change the function. It's like this can be like the lady before marriage and the lady after marriage. You are the same person, but what changes is your surname, because now this time you're gonna take the surname of your husband or yes, your husband is going to make your surname to be different. You understand? So the function, you have changed from one family to another family. So you're gonna also behave differently. The way how you function is gonna be different. Yes. And sometimes you can even, the accent can change. Yes. So this one is methanoate, is an ester. While this one is a carboxylic acid. You see? Carboxylic acid. You see? So it's different. So you'll find out that this one is like CH3. It's like that. While this one is like 1, 2, 3 CH3 COOH. You see, remember when I told you that carboxylic acid, the H must be at the end. While this one, it must have carbons between. You see? Yes. So this, we call them functional isomer. We will look at them into detail so that I explain it better, much more better. Yes. Don't you think we have completed our first class? Thank you very much for reaching our first class at the end. The next class, we'll talk about the IUPAC name and the formulae for compounds. Formula if it's one, formulae if there are many. So we're going to look at the IUPAC name. How do we name these organic compounds? And then how do we write their formulas? Keep on the channel. It has been M.Saidi. Don't forget to subscribe, like, and share to others so that they can also benefit from the content. Thank you very much. See you again.